So the next concept we will cover is modules and packages, which basically will show you how you can use importing to enable external packages within your own code. And the main reason to do this, which is kind of one of the fundamental powers of Python, is that since the language has been around for so long and since it has been used so extensively by other people, vast coding scripts as well as collections of these scripts and packages already exist to do advanced mathematical computations, graphical plotting, and all sorts of additional features. And basically, the power of this is that you yourself then don't have to go about writing this fundamental code. You can take and use this code and then simply further it with your own personal scripting for whatever project you're working on. And so, probably the easiest way to kind of understand and get an intro to this importing idea of different scripts into your own writing of code is to go back to our idle editor. And so previously, whenever I've been showcasing an example, I've been specifically just using one script. However, we can also create additional scripts and use these in conjunction with our initial with each other scripts via the importing feature. Now, firstly, before I go about doing this, an additional feature of Python which I haven't covered thus far is commenting. And in a programming language, basically a comment is some just kind of a standard, feature of a comment, which a programmer puts in for other people to read. So comments are ignored by the computer. They do absolutely nothing for the program when it's compiled and run. You simply put in comments so that other people who come to your code and read them can better understand what's going on. And so in Python, how you denote a comment that a line is going to be a comment is using the hashtag symbol. And so when you give this symbol, everything on this following line is then going to be completely ignored by the compiler. Else, if you didn't have this symbol, then this would actually then cause an error and the program to crash, since Python doesn't know how to interpret this syntax. And an additional type of commenting you might see is simply having a string within the code. It's actually perfectly fine to simply have a string just without, any variable initialized to it within Python code. This won't crash the program. And since this then, isn't being set to a variable or nothing's being modified, this basically then still acts as a comment in that it's not interrupting the flow of your program. You might also see multi-line strings as comments, which are basically strings which then wrap onto multiple lines of your programming code. And the syntax for defining those are simply giving 3 of the quote characters rather than a single one, followed by 3 at the end. And then this allows you to simply wrap your comment onto multiple lines, as can be thus seen. So moving back to importing though then, this comment at the top of each of these scripts is simply the name that these scripts are saved as in my file system. An important thing to note for if you want to import a script into another one is that these are in the same directory. And so we can then say in this foo function, define some function which simply prints hello from foo. And similarly in our bar function, we can define another function, giving it the same name as function, and then simply have it print hello from bar. So then within foo, we can simply call the function when the program is executed, and then if we run this module, we'll see that it says hello from foo. But what if, say, in this foo script, we wanted to access this function in our other script bar? Well, how you go about doing that is by using the import keyword. So the import keyword in Python allows you to import script code and other scripts into your own function or into your own code. So specifically, we would say import bar. And then if we wanted to access bar's function, we would write bar period function, and then use the open close parentheses to call it. So if we run this now, we see that when we call simply function, it prints out hello from foo. But if we do bar.function, it will call bar's function and print hello from bar. And thus, we can begin to kind of segment our code between different scripts and enable the power of importing. Now, additionally, if you wanted to only import, additionally, it's also possible at times that you might have multiple functions within bar. And so in this case, they're all simply the same functionality, and I'll just delete that for peace's sake. However, there are sometimes you will be working with packages and scripts which have hundreds of functions within them. And so it might be annoying to import all of them within to your workspace. So if you want to just import one or two specific functions, instead of simply importing bar, you can say from bar import and then the functions which you want to import as a comma separated list. So in this case, since we just want to import function, we just write import function. But if there were other functions, we could say, right, import function, import func2, func3, and so forth and so forth. Now, the only thing to note is that when you import in this manner, to run the imported function, you no longer actually write bar.function. You only write the bar.function when you simply import bar. If you do a from import, then how you call this external function that you've imported is actually just the function name. So you'll see if we delete this function definition within our own script and run this, we'll now have hello from bar is outputted when we call function. And if we try to do bar.function again, this will actually cause the program to crash, because in this case, bar itself was not imported. So you see that thus bar is not defined. So, however, you can see that we have an issue in that our imported function has the same name as one of our internal functions. And so you can see that if we try to run this initially, then we'll actually get a hello from foo, because when this function is imported, basically the function variable is set to this function from bar, and then the function variable then is set to the function from foo in these lines. And so then when we call the function variable, we see hello from foo is outputted. But what if we want to have both of these functions available, and we don't want to just simply import bar, we want to import this specific function? Well, that's where the as keyword comes in. So the as keyword allows you to rename an imported function when it's being imported into your script. So in this case, we can give the imported function a new name, for example, bar func. And so now you'll see that when we call function, it will call foo's function, and then when we call bar func, it will call bar's function. So thus function outputs hello from foo, and bar func outputs hello from bar. Now, besides simply importing functions as different names, you can also import entire packages as different names. So for example, instead of importing bar and then writing bar.function, we could also write import bar, for example, as b, and then simply write b.function, and so forth and so forth. So we can just see this example played out here through the slides. So in some external script, we have import the foo script and the bar script, and then we can see that running foo.fun and bar.fun outputs their respective messages. Additionally, you can use the as keyword to change the name of an imported package or function. as well as specify specific methods within the package to export. So now that we understand how you can import code into your own projects, now let's cover some of the useful packages and that you can import and how to use them. So normally to configure your project to take in external libraries, you have to use either a executable called conda or pip to install these libraries. However, within Itasca software, there's actually several pre-installed libraries which will provide most, if not all, of the functionality which you will likely have to use for mathematical modeling and solving. So the first of these is called NumPy. And NumPy basically gives you access to powerful n-dimensional arrays, which will allow you to do all sorts of linear algebra and matrix mathematics. The second library is Matplotlib, which is a powerful plotting library which allows you to make figures and graphs from any given data. The third is called SciPy, which basically gives you access to vast complex mathematical operations, anything from optimizations to ODEs, differentiations, and so forth and so forth. And the final library is called PySide, which is which is the backbone of the Itasca software GUIs itself. And so through the usage of PySide, you can actually modify and extend the GUI to make your own custom widgets for inputting or outputting and so forth. So the first package which we will cover, and which is probably the most important package to learn, is NumPy. So firstly, to preface this section though, NumPy and in fact all of the other external packages which I listed previously are very, very, very big packages. They contain hundreds upon hundreds of methods and functions, each which have 10 to 20 parameters. And so it is practically impossible to learn all of the functions and methods available. Now, within these slides, I'll cover simply the most important ones, but still, in addition to this, it's very important, even more so than knowing how to use the package, is knowing how to use the documentation of the package. So the NumPy documentation can be found at the following link. And going to this, we'll see the several links to different manuals, and you want to use the one for your corresponding version of NumPy, which should be the latest. So contained within the documentation are firstly several different tutorials which can help you kind of remind you of some of the beginning and overview of the features, as well as more advanced concepts as an introduction to them. But basically, to kind of use the documentation simplistically is normally if you have something which you want to perform on the arrays or within the package itself, you can simply search for that operation itself. So say you have a NumPy array and you want to take the mean, well, simply searching for the mean will then show you all of the different ways available within NumPy to generate a mean and calculate from some given array. So specifically, I'll be showcasing the NumPy arrays within the package. There are some additional features to that NumPy package, but typically though, if you have questions dealing with the arrays, you want to look for that numpy.nd array, which specifies the subpackage according to the NumPy arrays. So clicking on this link will then showcase us the documentation of the mean function within the NDArray subpackage within the NumPy package. And you'll see that it lists the parameters taken via the function, and since these all have default values, that means you don't necessarily have to pass functions in, as well as linking you to additional resources to read for further documentation. And typically they will also provide examples of how you can use all of the different functions. And it is just very important to kind of get used to reading through the documentation whenever you need access to some specific functionality. So simply though, NumPy arrays can be thought as very similar to the lists that we previously covered. So they're a sequence of values of the same type, though. That's the main chief difference, is that whereas lists contain elements of various different types, NumPy arrays have to have the same type. And in fact, if you pass in different types as an argument to when creating a NumPy array, they'll be casted to the same type. So if you pass in integers and floats, they'll then be casted all to floats. So that's an additional thing, is NumPy arrays will typically always contain numerical values. And that's because one of the fundamental features of NumPy array is to do very fast and efficient uh, mathematical computations on these arrays and matrices. So to create a NumPy array, we firstly import the NumPy package, and typically we import it as NP just as a general styling to shorten it so we don't have to write out NumPy every single time. So the first way to create a NumPy array is by calling the array function and passing in a list. So passing in a list of 1, 2, 3 will then create an array containing the elements 1, 2, and 3. Additionally, we can use the zeros function and passing in an argument of the creating size to then create an array of zeros with as many zeros as we pass in. Similarly, the ones function creates an array of ones with as many ones as you pass in. And then the arange function works similarly to the input to the range function in that it takes in either an initial argument and creates an array from 0 to the argument exclusively, or it takes in a start parameter and creates an array from that start parameter to the secondary parameter exclusively. So, as mentioned, the kind of fundamental power and purpose of using NumPy arrays is that they have been made highly efficient for matrix and arithmetical computations. So, say we create some NumPy array and, from containing the values from 0 to 5 exclusively. Well, one of the nice features is that whereas for lists, if you wanted to, say, increment every element or perform some mathematical computation on every element, you'd have to create a for loop and iterate through it. However, with NumPy arrays, you can simply write the variable and perform arithmetic. And this arithmetic will then be performed on the array with element-wise operations. So, for example, writing x is equal to x plus 1 will add 1 to every single element contained in the array. If we then divide x by 2, this will divide every element by 2. And furthermore, if we create some new array and then multiply these together, once again, this will then perform element-wise operations on the two arrays. So to access elements or portions of a NumPy array, the syntax is actually, once again, very similar to lists. So if we create an array containing the values 0 to 5 exclusively, to access the first element, we simply use the close brackets and pass in 0, the index of the first element, as the parameter. If we want to access a subarray, we can use the colon, passing in the first argument and the last argument, and the returned values will be from the first index inclusively to the last index exclusively. And finally, negative indices can also be used to access from the end of an array going forward. So one of the main powers of NumPy arrays are their multidimensionality. So as mentioned, NumPy arrays can become up to any n dimensionality as you wish and as is needed via your program. So if we say create an array containing the values 0 to 5 inclusively, we can use the reshape command, passing in our NumPy array as an argument, and then passing in a tuple of the dimensions that we want. This will reshape the array into that given matrix size. So specifically, we pass in that we want 3 in the first dimensionality and 2 in the second dimensionality. So practically, this means that we want 3 rows and 2 columns. And so this initial data is then reshaped into this format. Now, one thing to note is that if you specify your arguments or pass in an array which doesn't have the correct number of elements to reshape into this new dimensionality, this function will cause your program to crash. So you have to be careful that the number of elements matches the shape that you're trying to morph it into. So even in this state, your matrix is still zero indexed. So each of these rows has their own specific index starting at 0, and each of these columns have their own specific index starting at 0. And so portions of your matrix can be accessed. So to do this, we use the same syntax for accessing as a standard one-dimensional array, simply passing in the additional access points as further arguments. So in this first example, we access the 0th row and the 0th column. So we go to the row with the index of 0, the column with the index of 0, which returns the element 0. In the second example, we access the row with column with index 1, and the colon operand specifies that we want to access all columns in this row. So we return the row containing the data points 2 and 3. And in the last example, we specify that we want to access the rows from indices 0 to 2 exclusively, so from 0 to 1 inclusively, and we want to access all of the columns for that in those rows. So we then return the submatrix containing the data 0, 1, 2, and 3. Now, an additional power of NumPy arrays is masking. So if we go about through the same kind of initialization to create our matrix, we can perform Boolean, similarly to how we can perform arithmetic element-wise, we can also perform Boolean algebra element-wise on our matrix. So, for example, if we wanted to determine which elements of our matrix were greater than 3, we can write x is greater than 3 to convert our matrix into a matrix containing falses and trues, corresponding to where this Boolean condition evaluates to false and true. If we pass this mask in then into the open close parentheses of our variable, this will then get rid of all of the portions of our matrix where the mask is false, and only keep the portions where it is true. So this is honestly one of the most powerful aspects of NumPy because it allows you to specify different conditions and evaluations of your data and use it to then process your data set as well as perform computations upon your data. So the other main package which we're going to look at today is Matplotlib. So Matplotlib is the graphical and plotting library. And similarly to NumPy, it has a vast documentation which is available to cover its accordingly huge amount of functions and various different niche and specialty things available within the package. So we'll simply cover some of the more kind of fundamentals, how do you make a simple X versus Y plot. But if you wish to eventually learn, or if you need to create subplots, bar charts, graphical representations, and other features, it will be useful to go to this documentation and to then search through this to find the specific things which you need to learn. So this is a simple example of how to create a straightforward plot, simply given some X and Y data. So firstly, we import the pyplot sub-package from the matplotlib package. And it's kind of typical style to shorten this as simply PLT. We then use the subplots function to create a figure and axes as kind of the backbone of our plot. After initializing some x and y data, we can then use the plot function on the axes, passing in the x data and y data to create our plot. Finally, we can use the show function on the PLT subpackage to show our created plot. And after all that code executes, this will be kind of the state of our plot. So it's also possible to add some styling to the graph as well as plot additional functions. So within the plot command, you can actually pass as many functions to plot as you want. So you can see in this example, we initialize a variable t to contain data from 0 to 5 with a step of 0.2. And then we firstly plot t against t, and then t against t squared, and then t against t cubed. And these string arguments specify the specific styling of each plot. And if you worked with Matplot, or sorry, pardon, if you worked with MATLAB previously, the styling of these arguments is actually very similar to the plotting arguments within Matplot. So specifically, and you can look at once again the documentation for all the availability within the Matplotlib documentation. But what this first argument specifies is that this t versus t plot should be red and a dashed line. And then the second string argument specifies that this second plot should be blue squares. And this final argument specifies that the final plot should be green triangles. And so that's how you can specify the specific styling of your plots, and so using these string arguments. And so then if we look at this plot, we can see that t is plotted as a red dashed line, t squared as blue squares, and t cubed as green triangles. So that is all of the content that will be covered in this first lesson. And I hope that this introduction to Python and some of its higher level packages was helpful and useful to you. And in the next lesson, we'll be covering specifically then how you can use Python in conjunction with Itasca software and the bindings available within there to access model data and to perform calculations upon that said data. But I would strongly encourage you to try to start using this programming language within your own project, since it is a very powerful tool. And the best way to learn it is to just go about and do things with it, perform it within your projects or within your own personal scripting, and it will come more naturally to you. But I thank you again for attending this lesson, and I hope that you were able to learn more about Python.